All right, week 4, day 1. I have it in there that hang in there because we are just about halfway done and over halfway done once we finish this week, okay? So what we are going to start with this week is multiplying rational expressions. Now, as always, pause when you need to and play when you need to, okay? So what this is here is what is a rational expression. A rational expression is a ratio of two polynomial expressions. Remember, polynomial can be a number. Sounds silly. It could be something added and subtracted. It could be more than one term added and subtracted. It could be more than one term multiplied together. All of those are polynomial expressions. Okay? So an example of a polynomial expression that is a rational expression is something like when I take 2x plus 7 over x minus 3. That right there is an example of a rational expression. Okay, so we are dealing with fractions this week and next week. What I'm going to start with first is something kind of simple and to bring us into what we're doing today. How would you simplify 8 over 16? I would say most of you are going to go, oh, they have an 8 in common, you're going to divide. But what I want to challenge you to do right now is I want to write this as multiplication, okay? So this 8 on the numerator can be written as 8 times 1, okay? The 16 on the denominator, if I want to take what they have in common, can be written as 8 times 2. The reason why I did that is because today, when you simplify, your terms have to be written as multiplication in order to simplify, okay? So right here, what I mean by that is anything on the numerator and denominator that is the same, anything divided by itself is equal to 1. So this 8 over 8 is equal to 1. It will eliminate itself, and so that we have a final simplified expression of 1/2, okay? One thing that we need to talk about here is we are going to be dealing with a lot of fractions, okay? And something about fractions is that numerators don't really matter, okay? I can have anything on the numerator, no big deal, okay? The denominator, however, cannot equal 0. So when I go through each of these questions, you're going to hear me say, what is the value of x and y, or that it can't be? What is the value of a can't be? All types of things like that, all right? So here we go. First example, it just says simplify. I started with something similar to what we've done before in our past here. 30 BC divided by 12b squared. And what I'm going to ask first is, what's the value that b cannot equal? Meaning, what is the value of b that would make the denominator 0? And in this case, the only number that would make the denominator 0 anytime is 0, because 0 squared would make it 0 times 12, still 0. Okay? Now, I had you write the 8 over 16 a minute ago as multiplication with ones that are just like this, a monomial over monomial, one term over one term. You don't need to write it as multiplication. Meaning, if you see that, oh, 30 over 12 both divide by 6, and I could write that part as 5 over 2, then go ahead and do so. Using your exponent rules here, you can see, hey, I have a b to the first on the numerator, a b to the second on the denominator. Well, that means if I can eliminate some and simplify, I'm left with only a b on that denominator, and c cannot simplify with anything. Okay? The next one here, I wrote this as a factored polynomial already. Okay, so 2x times x minus 5 divided by x minus 5 times x squared minus 1. Now, it's not completely factored because that x squared minus 1 will factor further, okay? But when I look at this one here and I say, hey, what can x not be? I do not care about the numerator one bit. The 2x and the x minus 5 that are up here on this numerator, I do not care about, okay? What I do care about is this x minus 5 and this x squared minus 1. If one of those two terms, one of those two terms is equal to 0, then it means the entire denominator is equal to 0. Okay, so I'm going to take each term. I'm going to take the one that's over here on the left, x minus 5. What's going to make that 0? Oh, well, 5. So you know what that tells me? X cannot equal 5. Okay? Then I'm going to take the term that's on the right there, that x squared minus 1. Well, what's going to make the x squared minus 1 equal 0? Well, if I add the 1 over, x squared equals 1. I put the square root in, so positive and negative 1. So these are the values that x cannot equal in this question. Now, remember I said on the first page that it has to be written as multiplication in order to eliminate it or make it so that a term that's the same on the numerator and the denominator equal 1. This right here is multiplication. 2x times that x minus 5 is multiplication. X minus 5 times that x squared minus 1 is multiplication. That is why I can go ahead and say, hey, this x minus 5 over that x minus 5 is equal to 1. And I am left with 2x divided by x squared minus 1. Now, because this numerator is not written as multiplication, x squared minus 1 is not multiplication, this is my final answer. I cannot simplify the x's, okay, because my numerator and my denominator are not written as multiplication. Okay, that is as simplified as it can get. Oop. Alright, so here is my next example. Y squared plus 4y plus 4 divided by 3y squared plus 5y minus 2. Okay, so again, it has to be written as multiplication. So that means a big fat no-no would be to start going like this. Oh, look at that. I'm done. No. No, 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 no. No, no. Okay? They have to be written as multiplication in order for you to be able to simplify, meaning that on both that numerator and the denominator, you are going to have to factor. And that might take some side work off to the side to be able to do so. So what I want you to do is I want you to factor this numerator, what multiplies to 4 and adds to 4. Okay? You are also going to do the same thing with the denominator, what multiplies to negative 6 and adds to 5. So I'm going to go ahead and pause here, and you are going to factor both that numerator and denominator. Alright, so when you factor the numerator like I did over here in purple, and you factor the denominator like I did over there in green, okay, so factor it all out, there's what you should have, y plus 2 times y plus 2 for the numerator, and you can also write it as y plus 2 squared, 3y minus 1, and y plus 2 for the denominator, okay? These are now written as multiplication. Y plus 2 times y plus 2, 3y minus 1 times y plus 2. Now notice I have not said what y cannot equal yet. I waited until my denominator was factored to do so. Okay, so for starters, because of this 3y minus 1, y cannot equal, add the 1, divide by 3, so 1/3. And because of this y plus 2, y cannot equal negative 2. Okay? Now, I can eliminate anything that is the same on numerator and denominator, meaning right here I have a y plus 2 that is the same as this y plus 2. I can only get rid of one of the y plus 2's and not both because I do not have two of them on the denominator. That makes my final answer this right here. Y plus 2 divided by 3y minus 1. Right? So remember, they must be written as multiplication to eliminate them. And then I also need to write down what can the y values not equal in this question. Okay, so here we go. Now we're going to multiply. Alright, so it's taking the same concept here. So if you were to multiply fractions, what would you tell me? Well, right here you would say multiply that numerator, right? 2 times 3. Multiply that denominator, 5 times 8. Okay, you may have actually already multiplied them to say 6 over 40. And then after you multiply, well, you would simplify. Divide them both by 2 here, so 3 over 20. Okay, you could have also, for multiplication, cross-simplified, meaning this 2 goes into itself 1 time. It goes into that 8 4 times, and when you multiply, you have 3 over 20. Same answers. Okay, so here is our first multiply question. 4a divided by 5b times 15b squared over 16a to the third. Right? When I multiply these together, I am going to multiply the constants. Okay, 4 times 15 is 60. And I have ab squared. Denominator, 5 times 16 is 80. A to the third, b. I want you to go ahead and simplify that. Alright, so there's what I have right there. 60 over 80 reduces to 3 over 4. And I have an a squared on the denominator and a b on the numerator. Now, because up here at the beginning I had an a and b on both on the numerator, or denominator I mean, a and b both cannot equal 0. I want you to write this question down, pause, and try it on your own. Alright, right there is what you should have, including what y cannot be, because y is the only variable on that denominator. So here are these right here, m squared minus n squared over 4m plus 4n times m plus n times m minus n. What I'm going to suggest you do first always is factor, okay? So just a reminder that when I have a difference of squares, which is what I have here on this numerator, that factors like this. I have two perfect squares. It's been a while since you've done difference of squares. What's square root of m squared? Well, m. What's the square root of n squared? Well, n. And I can make a plus and make a minus. Okay? That denominator on that first fraction will simplify by taking out a 4 so that I have m plus n. And then that second fraction does not actually have anything that factors. Okay, when you have a weird looking example kind of like this one, the values of m and n actually can be anything as long as m does not equal n, because that's the only thing that's going to make this denominator equal to 0. Okay, now when you have multiplication here, you can use your cross simplifying, because this multiplication actually means that this is actually one big fraction. I didn't really show that very well as I was drawing that across, but this multiplication is one big fraction. Okay, that means anything numerator to denominator that's the same will eliminate. So my m plus n here, they can eliminate. This m minus n, because it's one big fraction, can eliminate. And then anything that's not eliminated is all I have left for my final answer. I have an m plus n on the numerator and a 4 on the denominator. Alright, on this page here, I just have a couple that I want you to try. I realize this last example down here is a lot of factoring, but what I want you to do is I want you to simplify these, pause it. All I'm going to put down is my answers, so you can see if you got it right, and then you are ready to go for the practice. Alright, there's what you should have there for the final answers. On the last one I did add what it should be when you factor it, and then what the final answer should be. Alright, thanks for hanging in.